We are continuing with the revision, and this is algebra once again. We have some algebraic expressions that need to be simplified here. The first one, a minus b minus 4b plus 6a. We need to simplify this one. The first step there is to collect like terms. We have a, and then the second one with an a, this is 6. So plus 6a, and then from there we have minus b, then minus 4b, and this is going to be equal to what? Simplify these ones, and then you simplify these ones. A plus 6a, there's a 1 here, so it's 1a plus 6a. This is 7a. These, both of them are negative there. So when both of them are negative, you just simplify them as if they are positive, but you give them a negative sign. So this is minus 1b minus 4b. We get a 5 there, but the 5 is negative. We are saying it's minus 5b. And then these two, we cannot simplify them because they are not like terms. 7a and 5b are different. So this is our final answer. Then the next question, we have three brackets, and where we have brackets, remember, it's multiplication there. So we are multiplying this by that, and even these ones, it's multiplication also. So it's negative 3 times a cubed times b7 times c times this times that times the all the way. But we have to collect like terms, those which are related, and then we multiply those ones because we can simplify those ones. Let's do that. There is a negative 3 here. This is equal to, I have a negative 3. I'm taking the coefficient here. The coefficient here, that is a 5. And the coefficient here is a 1. You should remember there is a coefficient there. Sorry. And then we have a 3. Let me use these full stops. These full stops mean multiplication. We have a 3, and then from here I have times a 2, and from here I have a. I've collected those with a's as a variable, and then I go to b. There is a b7, and then there is a b. That b standing on its own, you should know it's a b1, and then another b, and then that is all for the b's. And then we have a c here times a c, and then times, this is c2, that is c raised to 2, and then the last one is a c. So we have to simplify this part, and then we simplify this part, and then we simplify this part, and then we simplify that part. And this is going to be equal to negative 3 times 5 is negative 15 times 1 is negative 15. Using the first law there, the first law of exponents that says when the bases are the same, you add the exponents. So this is going to be a raised to 3 plus 2 plus a 1. Remember, this a is raised to a 1, but we don't normally write that 1. And then we have a b, 7 plus 1 plus 1, 7 plus 1 plus 1, and then c1 plus 2 plus 1. And this is going to be equal to negative 15a, 5 plus 1, it's a 6, b 7, 8, 9, and c 1, 3, 4. This is our final answer then from this question, right? Someone could have skipped these, not really skipped, but someone could have just done these two lines in their head by saying negative 3 times 5 times 1 is a negative 15. A3 times A2, that's A5 times A, that's an A6. And then B7 times B is B8 times another B, that's B9. And then C1 times C2, that's C3 times another C1, that's C4. And that is your answer. All right, let me clear my space here. You can always pause the video so that you pause the video, go to the back, make sure you fully understand it. And when you are done, try to do it yourself without really looking at the answers to verify whether you really understand it. All right, we need to simplify this one. This one is going to be equal to what? We look for like terms there. This is 2xy plus 4xy. No, this is yx. But are they like terms? Multiplication, remember, is commutative. And by that we mean to say a times b is the same as b times a. So this and that, they are like terms because we are saying yx, which also can be written as xy. So we can add these two, they will give us 6xy. And then minus inside the bracket here, let's put the bracket there. We have 3xy minus xy. What does it give us? It's like terms also, so this is 2xy. We have 6xy and 2xy, they are like terms. We can simplify there. 6 minus 2, we are left with 4xy. And then the next question, we have brackets first. Remember, Bodmas tells us to deal with brackets before we go out. So let's deal with this bracket and deal with this bracket just like we did here. How are we going to do that? We have distribution here by that, and then by that, by that. This is distribution here. A by C is AC. A multiplied by negative 3 is negative 3A. And then we have plus C multiplied by A is plus AC. And then plus C or positive C multiplied by negative 2 is a negative 2C. Now, when you write these, when variables are being written together, just write them in alphabetical order. So we start with A before we go to C. You could write it as CA, but for order, just write it as AC. All right. Now, do we have any like terms here? I do see like terms. We have AC here, we have AC here. AC plus AC, remember there is one AC, this is one AC, so it's 2AC, and then minus 3A, and then minus 2C. And from there we do not have any like terms. This is AC, this is A, and this is C. All three of them are different. Okay, let me clear that, and then we go to the next question where we have division here. I'm going to put it here. Minus 16a3b2 plus these two are different. They do not have like terms there on top, so we cannot simplify them, but they have a common denominator. We need to separate these two. Both of them are being divided by this same, so we can rewrite them separately with the same denominator there. So we have negative 16a3b2 over negative 4a2b4 plus, we have a plus here, so it's plus 4a squared b raised to 4 over, by the same denominator, minus 4a squared b4. You see, we have the two terms there on the numerator, but we had one denominator there. We have separated to write the same, this by that same denominator plus this divided by the same denominator. Now we can simplify making use of the second law. that law on division, which says if you are dividing the same basis, then you subtract the exponent. So negative 16 over 4, negative 4 is a positive 4. When you divide a negative by a negative, it's a positive there. We have a3 over a2, so it's a raised to 3 minus 2, so we get an a there. And then b2 over b4 is the same as b raised to, that is b raised to 2 minus a 4, that is a b with a negative 2 there, b with a negative 2. And then coming to this one, plus 4 divided by 4, it's a negative 1, right? So I'm saying plus a negative 1. And then we have a squared over a squared. They cancel each other. They are the same. b4 and b4, they cancel each other. So it's 1 and 1. Just multiply. Here we have a negative 1. So negative 1 times 1 is just a 1. And then our final answer. Then there is a rule that says you don't leave your answer with a negative exponent like this. We make use of that rule which says a raised to a negative m is equal to, this is over 1. So when it has a negative exponent on the numerator, take it to the denominator. We have 1 over, when you take it to the denominator, the coefficient there is left there. So it becomes a with a positive m. If it was 1 over a with a negative m, you take it to the numerator there, so you will have a with a positive m over 1, right? So when the exponent is negative, just take it up or take it down so that it becomes positive. So this b raised to a negative 2 should go to the denominator. We have 4a over b with a positive 2. Positive and negative will give us a minus 1. All right, that's all here. The next question, which happens to be the last one there. Sorry, we have the whole cube root of square root of this minus square root of that. The first thing, when you have negatives following each other there, remember it becomes positive. And then this is a square root. So we are saying this is cube root. We first deal with what is inside before we go out. So square root of 36, we know it. This is a 6. And then when it is a square root and we have an exponent inside, we just divide that exponent by that 2. So this is x with a 12 over 2. And then we said we have an addition here. Square root of 4. I've written this 2 just to remind you. But when you see a root that does not have anything here, you should know it is square root. But when it is a cube root, we do write that 3. So square root of 4 is a 2. And then the x, the 12 inside, you divide it by the 2 which is coming from here. So this is 12 over 2. And this is equal to the cube root of 6x6 plus 2x6. And these are like terms, so we can simplify it to be the cube root of 8x6. 8x raised to 6. Probably I should rewrite it. Raised to a 6 there. And then simplify it from there. We do know the cube root of 8. The answer is here. The cube root of 8 is a 2. And then this 6, you now divide it by 3 to get 2 there. 6 divided by 3, you get a 2. Now, the reason why we are dividing there, we said when it is a square root, you divide by 2. When it is a cube root, you divide by 3. This is because anything that is written like this, a, right? This can be written as a raised to 1 over 2. If it is cube root, this can be written as a raised to 1 over 3. You see, what is outside comes here and becomes the denominator on the exponent. Now, if we have, for example, probably a raised to a 5 and it is under the square root, that 2 here will come and become the denominator just like here. So we have a 1. In this case, it's no longer a 1, it's a 5 now. 5 over 2. And if it is a 4, which is under the cube root, this will be a 4 over 3. That's why here we're dividing. For this one, we divided that 12 by the 2, divide by the 12 by the 2. But here, after simplifying, we simplified here 8x6. We divided the 6 by the 3 to get 2x2. That is all for now.